Okay guys, in this video we're going to talk about nuclear reactions. So nuclear reactions are different from chemical reactions in that the nucleus is actually changing. So in the changes we've talked about so far, we're just talking about atoms rearranging. Now we're talking about the one specific atom actually changing, and the nucleus is going to change. So what happens is, as a result, the identity of that atom is also going to be changing. So an element is going to be considered radioactive if the ratio of neutrons to protons is greater than 1.5 to 1. So when this occurs, the element is going to be unstable and must come apart to stabilize. So let's practice this in order to figure out if something is radioactive. So you're going to take the number of neutrons divided by the number of protons and then put your answer in ratio form. So let's practice with uranium-238. So is that radioactive? So we have to figure out the number of neutrons. Remember from our previous lessons that you take the mass number, which is 238, minus the protons, which is 92. So 238 minus 92 is 146. Divide that by the number of protons, which is the same as the atomic number, 92. If you divide that out, you get 1.58, etc. It's a long decimal. So that is higher than 1.5. So the answer is yes. Uranium-238 is radioactive. So what does that mean? It can undergo some type of radiation. So here's 3 different types of radiation. There's alpha radiation. In alpha radiation, you're going to have 2 protons and 2 neutrons released from the nucleus. And what that's going to look like in an equation is it's going to look like either a helium atom, or it could look like the little alpha symbol guy. And all kinds of radiation you hear about is dangerous. And so all you need to protect yourself from alpha particles, because they are so large, is just a piece of paper. Beta is going to be 2 electrons from the nucleus. And that's going to look like these guys over here, but there'll be 2 of them. So you'll have a little e, and then the mass of that is 0, and then the charge of that is -1 here. And those are going to be smaller particles, right? Because electrons are tiny. And so we're going to need something more substantial to protect ourselves from that. So just aluminum foil will protect us from that. You may have seen some people making fun in some movies about aluminum foil headsets or something like that, or putting aluminum foil in the windows to protect ourselves from being spied on, and that's where that comes from. Gamma radiation is the strongest, and that's just going to be some energy from the nucleus. So we're not going to really discuss that because there is really no formula that we need to talk about, but that would look like a gamma symbol, and that would need lead to protect us from it. So this is kind of what we're talking about when we get an x-ray. You wear a lead vest, and so it protects our internal organs from gamma radiation. So in our problems, if it says a proton is being released, it would actually be a hydrogen atom, and it's going to look like this, a hydrogen, which has a proton, and then the mass would be 1 for that proton. If it says a neutron is being released, it will look like this, a little n for neutron, and then the mass would be 1, and then 0 atomic number. Okay, so on to the problem. So what will the problems look like? Well, you're going to have some alpha and some beta examples. And so remember, we went through the different amounts, and sometimes they're going to look like this, and sometimes they're going to look like this. So let's just go through some problems here. So for this first one, okay, so you're going to have 2 sides of the arrow. And basically, remember that law of conservation of mass, and that still holds true. It just is going to look a little different. So the total mass number on the left side of the arrow is going to equal the total mass number on the right side of the arrow. And the total atomic number on the left side of the arrow is going to equal the total atomic number on the right side of the arrow. So the top number on the left is 212. So that means the total top number on the right should be 212. So we already have a 4 there. So if we subtract 212 and 4, we should get 218, which is not right. That should be 208. Okay, that should be 208. And then do the same thing on the bottom. So 84 minus 2 should be 80. And then to figure out what letter goes there, you look up 82 in the periodic table, and we find out that 82 is lead. Okay? So we're going to do the same thing on the next one. So on the left side, we have 242. On the right side, we need 242. So we have 238. So we need a 4 in there. On the left side, we have a 94. On the right side, we have a 92. So we need a 2 in there. So what on the periodic table is a 2? Well, that would be helium. And that's really all there is to it. Now the beta could seem a little trickier. So for example, down on the bottom, we have a 40 and a 40. So that would be a 0 there. And then we have a 19 and a 20. And you're thinking to yourself, well, how the heck did that happen? Well, that's where our negatives come in, and that's where our electrons come in. Okay, so that's that beta radiation. So same thing down here, 78 on the left, so we have 78 on the right, and 33 on the left, and so since we have a negative guy, that gives us a 34. So that is selenium. Okay? Okay, go ahead and pause the video now, and I want you to try the next 4 practice, and then you can press play and we'll see how you did. Okay, so now that you've had time to practice, let's look and see how you did. So on this first one, remember the left and right have to be equal of the arrow. So left we have 137, on the right we have 137, on the top that's the mass number. So our mass number on the unknown here is 0. On the left we have 55. On the right we have 56. So the only option is a -1. So a -1 means we have to have an electron there. Okay? On the next one, we're talking about the arrow being a dividing line. So on the left we have 241 plus 4, so that's 245. And then on the right we have 2 1s. So that's 243. 243 plus 2 would be 245. And then on the bottom, it's going to be exactly the same. So 95 plus 2 would be 97. So if you look up 97 on the periodic table, we're looking at BK. Number 3, on the right side of the arrow, we have 28. So on the left side of the arrow, we have to have 28. So we have 27 already, so that leaves us with a 1 right there. On the bottom, we have 13 on the right, so that means a 0 on the bottom. So that would be a neutron. And on the last one, on the right side, we have 13 on the top, so we have 4 on the top of the left one, so that would be a 9. On the bottom, we have a 6 on the right, a 2 on the left, so that would be a 4. And number 4 is beryllium. Okay, I hope you're getting the hang of it. We're going to learn one more new thing, and then we can go ahead and practice.